Hi, I will use this video to introduce you the theory behind today's lab. As we will be studying in the class all the forces of that in the nature. Actually, there are four fundamental forces. They are all different kind of forces. But in this lab, actually, we focus on the gravitational force. Okay, let's just ignore everything. I will talk about the gravitational force. Gravity is very common force you experience every day. However, we only experience on top of Earth, but in general, it is described by this formula due to the Newton. And this is so-called universal law of gravity, where two objects with different masses always attract towards each other, and they are expressed by this formula. Okay, the force strength between these two, it will depend on the mass between these two. Okay, which means the bigger they are, the stronger the force, and also it depends on how far apart these two objects are. But the force is inversely proportional to the force, which means the farther away, the weaker the force. So that's formalized by this formula. But Newton is claiming that there's always a force between any two objects. But why don't we see the two objects that attract each other? Because they are just very weak. Because this constant G in front of it, which we saw the gravitational constant, is very weak, and that's make it almost invisible. If you just take up two items in your hands, you don't feel they're attracting. But even that theoretically they are attracting each other, but you just don't feel it. Well, this will be significant if one of these objects is as big as the Earth itself. Okay, and Earth has the mass of 9.1 10 to the 1/3, and then there is another regular object which is small, let's say a handheld, a phone, cell phone or something. Then that will be significant. So then that's what we are thinking about, applying this formula to different things. And when objects experiences a force, and it will have an acceleration, okay, and the acceleration will be in the same direction as the force, and then the acceleration is inversely proportional to the mass. In fact, we will study actually the acceleration is actually towards the center, and it depending on how fast it moves, it go by this formula, which means if you have an object, right, and pulling surrounding a circle around a center object, the centripetal force, the acceleration is in this direction. In this direction, it's A. Okay, that's vector. It has a direction, but its magnitude, if you think about how big it is, take its absolute value. It is proportional to how fast moving in a tangential direction. So therefore, it's V squared divided by R. So we'll get back to this formula later on, okay, in the class. So I just give you a head up. You will need to do the vector analysis. So how it changes, how it goes, and use some of your previous knowledge of the radians and arcs, and then going through all these steps, and then you end up with this formula. But for now, we just remember the centripetal acceleration is towards the center, and it is with this magnitude. So the acceleration is to the center and with this magnitude. Now, so in this case, in the case of this lab, okay, and then in this case, the force is actually a gravitational force. Now, we have, say, a Earth, right? And then an object that's flying. Okay, we can make it flying, but then it's always experience a gravitational force, G. okay, force G. Okay, the differences are this bigger scale. Okay, and the acceleration is always in this direction. But if you think about giving a satellite some velocity going that way, all right, so then if the force is going this way, which way will be the acceleration? Acceleration obviously is the same direction of force, this way. Okay, that acceleration make the velocity to change, and then it will bring it this way. Okay, so bring this way, so it'll go that way. And of course, when it goes here, the gravitational force is always to here. Okay, and then it will keep on making a turn, and also probably faster even, and go that fast, and then it will go in here, and then boom. So this is what plays in between a big object like Earth, huge mass, and a small object, and like say a satellite, or simply some basketball over here. Okay, if basketball is too close, so it's moving, it just boom, bring it down here. But if you throw a basketball here this way, but since it's too close to Earth, thus we're gonna boom, boom, it hit this. Only when you take it very far, like in the place of the satellite, and then it will go here. Okay, the basketball will go here, boom. Okay, but there are some sweet spot. You have some speed, and boom, and then you keep on burning, and never dropping. So it goes into a orbit. So the orbit is actually a balancing effect between the object's natural tendency to go a straight line, which is Newton's first law, and it's being yanked back by the gravity continuously. So that's a balance. But the gravity will never make it touch the ground, but the object will never get to go away. So therefore, it balances into an orbit like this. So this lab, we just play with this and see how you can get an object to circling around the Earth. That's a simulation. We have a simulation of the gravity and an object. Okay, now we just give you a heads up of how the gravity is supposed to work. Now you unzip the folder, you will see this satellite folder. That's a software, and then you download this on a PC, and you will see this file, and you double click this one, and don't double click any of this, and you will see this. So you'll see this. So that's what we're going to play. All right, so you see the Earth is attracted to this, and then as I said, they're attracted to that. Like normally if you have a basketball, look at the green one, let go, it attracts the bounces. Okay, if you toss the basketball, it will just look like a parabola, and just like last time we did. Okay, like a parabola going like this. But now you see the point of this. But if you go very far, the attractive force goes away because the r square is on the bottom. So but it does accelerate towards the Earth. So look at the green, white ball, and wow, okay, it's bumping away. This game does a lot more than just similar. So that's going here. So now if the Earth, if it goes too fast, it has more energy, it can get to escape. Boom, see, it's gone. So you use your mouse to grab this, left click, you can grab this around, and then boom, send them away. Because if you send it too slow, and then you get attract back. Okay, but this green one will come back because it will go too far away. The Earth is attracting it, and later on will attract it, come back. So that become trapped in the orbit. It will go back in the view, but it's kind of slow. But this takes so long, but in fact it's still in the view. Let me stop this one, and once again start this one. Okay, the goal is to get this thing to circulate. So you don't want to go too fast, but you want to go slow. So here, now see, I try to get the green one to orbit. Or the white one? No? Okay, let me get the green one to orbit. To orbit means to circle around, not touching the Earth. I grab the yellow one. Let me try yellow one. Okay, the yellow one seems, oh no, it's still hitting. Alright, so this is actually a game I was developing. So now, so the white one seems circling now. Let me get the yellow one out of the way. Alright, see the white one is circling now. The yellow one is circling now. Uh-oh. So now the green one, keep going. Green one go out of scope, it will come back. I will stop this one or mess this up. Okay, so the white one's still going. You see, right, I will do this. Uh-oh, yellow one's still not good. Let me go this way and okay. Now, see both of them are circling around. Uh-oh. Okay, the goal is to get all three of them all circling without bumping each other. And actually, we are developing a 3D game called Gravity. So then, this simulates what happens with the satellite. Okay, it's nothing but Newton's second law and gravity in play. Okay, it just simply, you can think about a satellite or moon. They are actually dropping. Okay, but it never touch because it goes too fast. So for example, the white one, it still sends the Earth, but then Earth will bring it back. Okay, all right. So that's the goal. And then this lab is just fun. You need to take a picture or take a video of your case. If you succeeded, take a short video showing that you have at least one of these ball circling, and post it onto Instagram or YouTube and put the link in your lab report. And also answer a few questions about there's a question in the lab. So that's this preliminary theory. We'll talk more about gravity and gravitational motion and the satellite and planet motion in the class. All right, have fun. Bye-bye.